Hello everyone, welcome to next video tutorial on the polynomial. You represent polynomial using linked list. In that, how to represent an polynomial expression by using an linked list. Okay, here we are using set of variables like this is an example of an polynomial. It contains the constant and xyz variable and their coefficient, okay, and the power of those values. You can say that it can be a quadratic equation. Then here cf indicates coefficient value, then px indicates power of x, power of y, then power of z. It is a single linked list, so it contains only one link that holds the address of next node. Okay, and how we represent a single linked list? It contains two fields. Each node contains two fields. That is, one is information field, and the one is the link field. Okay, here the information field is partitioned into four fields like coefficient, power of x, power of y, and power of z. That is represented here. And another field, the second field is the link. It is as it is. Okay, and we can represent this like the same one. The next is here how to represent the entire equation like 5 is the coefficient, then power of x is for x is 3, then for y is 2, then z is 2. Then in link contain the address of next node. Then similarly second term, x and z values are 0, only y coefficient we have, that is 2, that we keep placed here. Similarly we represent the third node. Here y coefficient is 0 and it is the end of the linked list, so the last node of a linked list uh, contain the null value that we represented here. Then how to represent the singly linked list of an polynomial using an head node. So it is a given linked list for first node, second node, and third node. If last node is only 6z is there, if I want to add that one, you can add it here. 6 x y coefficient 0, z is 1. That is last node is 6z now, so it is ends with a null character. Link field ends with a null character. Then same expression can be represented with by using the head node. Okay, it is a head node. We're attaching the head node at the beginning of each of the linked list, and it is example for circular linked list also. Why? Because here earlier the last node link field contain the null value to indicate that it is an end of the linked list, but here the last node link field contain the address of the first node, so it is an circular linked list with header node. Okay, then how to insert an new node uh, to the rear end. As you already know, like initially what we are doing, we are going to create a temp node by using get node function. A node is created. For that we are assigning the name temp. Then to that new node created, for example, if I have taken, this is the new node created. For this I have taken the name temp pointer cf px py pz. You have to assign, you have to insert values in it. So we are obtaining the values from the user and we are assigning those value into it. Then current equal to head pointer link. Okay. So initially the first node will be held by the current. Okay. Current equal to head pointer link means that we start from head pointer link is this one. Directly we store this first node in the current only. We are not taking as a first node. Directly we take it as this is current node only. Okay, current pointer link not equal to head. It means that it will keep on increment the values until current pointer link, this is current pointer link, link is reaches to the head. Until that we have to visit each node one by one. For that we are increasing the value current equal to current pointer link, so visit each node one by one until it reaches to the last node. Once it reaches to the last node, to that node we have to insert, for example, this is the last node. For this, if you want to insert the temp node at this place, you can insert. So how to do? And earlier the current pointer at least the last node link contain the address of head node. Now this last node link field should contain the address of temp node. Here I have to provide the address of temp node. So current pointer link equal to temp. Then temp become the last node. Then temp pointer link is equal to head. So new temp node is added at the rear end. Then always return the first node. The first node is head here. So return head. Then next is how to uh, read the polynomial. Okay, how to read the polynomial? Just like we're reading each of the values one by one. Enter the number of terms in the polynomial. For example, if it contain 4 terms, you have to read all the 4 terms one by one. Here for I equal to 1, I less than n, I plus plus. Okay, it means that the first node, second node, third node and fourth node, all of them will be read one by one. In each node, if I enter into the first node, read each of the values, like read the coefficient. You have to read the, this is the first node, second node and third. Initially for I equal to 1, we start from this, read all the values like 5 3 2 2. Okay, those are coefficient, power of x, power of y, power of z. Read one by one. So we're reading all of that by using scanf value. Then if I inserted the head equal to insert at the end. If you want to insert a new element, you can insert at the end of the linked list by using insert rear. Then return head. Okay. Then display function. How to display the entire polynomial? So initially we start with the check for is it an em- empty linked list, means that the circular single linked list contain only the head node. Okay, that time I would check that if head pointer link pointed to the head only, it indicates that uh, the linked list contain only head node, no other node. That is why it is called as an empty linked list. Then return the values. If it is not empty, then go for the next step. Temp equal to head pointer link. I'm taking the first node as the temp now. We have to read each of the node one by one. Either you can take temp or you can take the current. Okay, you have to read one by one. Temp not equal to head. Start from first node to till it reaches to the last node. Read all the values. If temp pointer cf is less than 0, okay, if the coefficient is 0, that term you just come out of that value. You can print negative coefficient. Okay, in our example, no coefficient is empty. All are the coefficient, it contain the values in all the values. Like here also positive is there, positive, positive and positive, means that coefficient is not equal to 0 or to not less than 0. Then we'll come to the next one. This will get executed for this given statements. Okay, uh, printf plus percentage temp pointer cf. Okay, for each one you have to add the plus symbol after reading each node. If temp pointer px not equal to 0, it means that this value, is it equal to 0? No. Then print that value temp pointer px. Similarly, y coefficient is 0, no, then print it. Then z coefficient is 0, no, then print it. Then temp equal to temp pointer link. So go for the next node. Once first, if you once completion of displaying the entire first node, move for the next node. That is why initially I have taken temp pointer link. We come for the this node again. Read all the values and display it. Okay, this is how the display operation is performed. Next, how to evaluate. Evaluate means I'm going to add uh, I'm going to evaluate the given. Okay, how to evaluate means you have to read each of the coefficient and power of x. Then after reading all the four values from each of the node, then you have to add it. For example, here I have taken the the coefficient of first term is 6221. Coefficient of the second term is -4, cf -4, px, py, pz 0 1 5. Similarly the next third and fourth term. Then after doing we perform addition of all those, like 6 minus 4 is 2, 2 plus 3 is 2 plus 3 is 5, 5 plus 2 is 2 then minus 2, like that you have to perform all the values and perform the operation. Okay, we have to perform like here taken x equal to 1, y equal to z equal to 3. So after reading all the values, you have to multiply with for example here I'm taking 6, then x value I taken 1, then coefficient I'm taking 2, 6 1 raised to 2, then 2 y is 2, 2 raised to 2, z is 3, 3 into 1, like that you have to multiply. After performing operation evaluating all the things, you will get some answer. Okay, so whenever you call evaluate function, we have to read the coefficient. Here I'm taking the enter the value of x, y, z. Like I'm asking for x, y, and z. Then scanf percentage d, reading all the values like x equal to 1, y equal to 2, z equal to 3, like that. Then uh, p head pointer link. Okay, I'm taking for copying the once evaluation is done, at the end I want to get the answer. For that I'm taking p equal to head pointer link. We start reading each value one by one, like read each of these terms one by one. Then while p not equal to head, so it is the initial head, we have to read all the nodes, so read one by one until it is to the end. Then sum plus equal to p pointer cf. Okay, p pointer cf is we got coefficient of the first one, coefficient of one is 6. Okay, then into power of x and p pointer px. Power of x is like here power of x is 2, that to multiply with what, multiply with x value, multiply with the x value. Okay, similarly how it will perform, like 6 into 1 into 2, then 2 into 2, then z equal to 3, 3. So the entire values will be evaluated, like it will move for the next node. So it will keep on doing this. At the end, once we evaluate one, you have to perform sum plus, so next node will be value will be added. Keep on, so once completion of adding the end one value, move for the next node. For example, first one, what is the answer we got, like 6 into 1 into 4 into 3. So what is the answer we get, that will be sum. Okay, then move for the next node, p equal to p pointer link, go for second node. Is the second node equal to last node? No, again get inside sum plus, sum equal to sum, so previous value of sum plus reading this entire new value, that time it will read this value. Okay, 4 into y value is 1, 1, z value is y value is 2 into 1, then z value is 3, 3 into 5. So multiply that, again you will get, again we have to add it to the sum, keep on do until we read all the terms of an equation, then final answer will be obtained at the sum displayed. This is how the polynomial representation and uh, evaluation will be done. And polynomial addition, that we already know in the uh, first module, the same concept you have to copy for reading, writing, and displaying each of the terms. um, this becomes the end of the third module. Okay, thank you.